One important tool to balance the work within a cell is called operator balance chart. So the operator balance chart is a tool that's used to understand what is the workload of each worker into a cell or a line. So what you do here is just an example. You have here the time and this axis. You have the operator here. You can have multiple operations. You're going to see others. And you divide the work between work elements, okay? And the work elements, this is, for example, install of an instrument panel. In this case, we have 5 work elements. So you're breaking down the steps and takes about, let's say, 100 seconds here. So you're taking the 100 seconds that is the job of the worker and dividing into those elements. An element is the lowest amount of time, work time, that I can divide. Okay, so let's say I cannot divide in more elements than these 5, and because one worker have to do a whole element. So okay, so let's say that you cannot break things that multiple people cannot do. So maybe a better way to understand that, if the idea here is that the element will be the smallest part that I can pass to another worker if it's necessary. So if I say it takes too much time, let's pass element 5 to the next worker, I can do it. It is already divided in that way. Well, why to do that? Because I want to understand if they can produce according to the pace of the customer. And the pace of the customer, we're going to call it takt time. Takt time is actually the only word in the lean vocabulary there that's not in Japanese. That's actually in German. Because the Toyota people went to Germany and learned with the German manufacturing this concept that they were using, and they're using the takt they call takt time to find the pace of the production line, right? So in music, if you guys play an instrument, there is I forgot the name of the thing that mark the pace. And it's something that goes like this: click, 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 click. I think it's metrometer or something like that. So that time, you can set the time, the beats to be slower or to be faster, right? Depending on the pace that you want to play your instrument. So that's the idea. That's the rate of the customer demand, okay? And I use that to plan all the resource that I'm going to have in my plant. So I don't want to be faster than the takt time. I don't want to be slower than the takt time. I want to be just about the takt time. Because if I'm faster, it means I'm going to produce more, and I'm going to create a lot of waste, a lot of inventory, a lot of waste. If I produce less than the takt time, I'm going to produce less than I'm supposed to be, and I'm going to sell less than the customer wants, right? So I'm going to use all this, and it's very, very important because it aligns all the production processes into that time, okay? And this is the math. We're going to do the math with an example, but just for you guys to understand, is total available time divided by the amount of products. So that's the pace of the customer picking up a product, okay? Let's say it's 120 seconds. Every 120 seconds, the customer needs a product, so I need to be faster than 120 seconds. And this is the maestro, right? So this is the guy that's making sure that all the processes are occurring in the same pace as they're supposed to be. Why do I need to know the takt time? Because remember, we have the operator balance chart, we have the workers there, and they have to produce according to the takt time, right? So you have here the work elements. So this is how we use the operation balance chart. I have here the time. I have 4 operators in this cell. Can we produce according to the takt time? Yes or no? Yes, you can, right? All of them are quicker than the takt time. But I have some wastes here in the process. So the difference between the time, the workload of the operator and the takt time, that's the amount of waste that I have. Okay? There's another concept called planned cycle time. So planned cycle time is saying, okay, there's some variation going on in the process. So if I produce exactly according to takt time, I'm not going to make it to the end of the day because the variations higher and lower will not match themselves. I'm going to lose production to small little variations all the time. So I have to be a little bit quicker than my takt time, a little bit of wiggle room, not 20%, usually 10% or 5% for manual and about 20% for automated process. Then I have to have some wiggle room there, okay? But my goal is to reduce that wiggle room, of course. So I use that to balance. What happened if, let's say in this case, I have an operation balance chart. My worker is here. I have 3 elements. If in the future state, the takt time reduces, basically mean my demand increase, right? Then now I cannot have 1 worker in this cell. I have to have 2 workers in this cell. So I can divide the work element, it was on the top, put it to another worker, and then I have 2 workers doing the job. So that's the important part of the element and the work balance chart. To balance the workers and the work within the workers, I think that will work, according to the demand of the customer. Remember, flexibility is a key part here, okay? And this is it for continuous improvement. We're going to go to visual management on our next video.